edition of Unit 9, Circles When They Attack. 9D, it's a little bit harder than 9A and B, what we've done so far in C. It's not as hard as what we did last unit, but there's either a formula you have to memorize or a concept that you've used for years and years that we need you to understand. So the objectives today are that you can calculate the arc length of a circle and that you can find the radius or diameter given the circumference of a circle. Okay? So those are two things that we're going to look at, and we're also going to look at arc length. All right? Let's take a look here. First, circumference, the definition of circumference and the formula for circumference. So the definition of circumference is the perimeter of a circle, okay, just the distance around the circle. And then the formula, this is 2 pi r or pi d. So if you were asked to find the circumference of the circle on this problem, it's pi times d. The d is 12, so it's just 12 pi, okay? This is really just that simple. It was that simple when you learned it, when you were all much smaller. Some of you were much smaller, some of you were waiting for that growth spurt. Here, C equals 2 times pi times r. 2 times r there is 16, so here it would just be 16 pi. Easy enough. Practice with circumference. So if the circumference of a circle is 36 pi, find the radius. And it says leave in terms of pi. Okay. This one says round to the nearest tenth, and this one says leave it in terms of pi. When it says leave it in terms of pi, that just means that we're not going to multiply anything by pi. If we have to for our answer. So here, circumference of a circle, C equals 36 pi, right? Well, C also equals pi d and 2 pi r. Since we're looking for the radius on this one, I'm going to use this formula. So if C equals that and C equals this, then the substitution property says that I can write 36 pi equals 2 pi r. When I divide both sides by 2 pi, using my amazing algebra skills, for the radius, I magically get 18. It's not magic at all, by the way. If the circumference is 22, find the radius. So again, C equals 22, and C equals 2 pi r. So 22 equals 2 pi r. I'm going to divide both sides by 2 pi, and the radius is, now for this I'm going to use my calculator, and I'm going to put 22 divided by, and then in parentheses I'm going to put 2, and if on the Casio, if I hit shift exponent, that gives me pi. Okay, find that button on the TI. If you can't find it, keep looking, it's there. 22 divided by 2 pi is 3.5. It says round to the 10th, so 3.5. If the circumference of a circle is 25 pi, so 25 pi equals, find the diameter. 25 pi equals pi d. Divide by pi, and d equals 25. Those are simple, and yet you would be surprised at how often people miss those. Okay, let's take a look here. This is more complicated. Okay. Let's see. Given a circle with a radius of 7, all right. We're going to work with this circle right here on the right. Okay. This circle has a radius of 7. B is the center. The circumference is 2 pi r, right? So in this case, that is 14 pi. Everybody agree? I hope so. What type of angle is angle ABC? What's that, you say? It's a central angle? You are correct. What is the measure of the arc AC? Well, the measure of the arc AC is it's 1/4 of a central angle and circumference. Okay, this arc is 90 degrees. What is the arc measure for the entire circle? Okay, the arc measure for the entire circle is 360 degrees. That 1/4, this arc is 1/4 of the whole thing. Okay, the length of AC, there's that 1/4, is 1/4 of the total circumference. All right, since the measure of the arc AC is also 1/4, or 90 over 60, of the total arc measure of the circle, then by substitution, we know the length of AC is 90 degrees over 360 degrees of the total circumference. Okay? Here's what that means. If this arc is 1/4 of all of the degrees, then the distance should be 1/4 of all of the circumference. That's all we're saying. Okay? I'll repeat it one more time. This arc is 1/4 of the total number of degrees. So this arc should also be 1/4 of the total circumference. Okay? That's proportional. Proportionality exists. Okay? Now, some people like to use this formula. So arc length. The definition is it's a segment of the perimeter of a circle, or a fraction of the circumference. The formula for arc length is 2 times pi times r times this Greek letter here, theta. Okay? Theta over 360. And theta is the measure of the central angle. Okay? That is a way to figure out the arc length. I'm going to show you another way also. And if you like the formula, you use it. And I'll show you both and you pick. I'm going to tell you I'm partial to this. That the part over whole concept equaling the part over the whole. Okay? And here's what I mean by that. The angle, or arc length, okay, over 360 equals, the angular arc measure, sorry, that's in degrees. The angle in degrees, or arc in degrees, over 360 should equal the arc length over the circumference. Okay? And here's why. Because of what we just said on this previous page. Goodness gracious. That portion in degrees over all of the degrees is equal to that portion in length over all of the length. Okay? These are the same thing. All right? Don't get it twisted, as they say. It's just how you set up the problem. I like setting it up like this because it lets me cross multiply, and I'm really good at cross multiplying. If we were to take this problem up here, the formula, and divide both sides by 2 pi r, which is the circumference. This right here is the circumference. If I were to divide both sides by the circumference, this is what I get. Okay, so I like using this form of it, and I'll show you why. Okay, find the length of each arc AB. All right, so we're going to go part over the whole equals part over the whole. So this angle is the same as this arc, right? We know that because it's a central angle. All right, so 50 part of the degrees over 360 all of the degrees, okay, equals part of the length, part of the circumference, that's what we're looking for, it's what we don't know, over all of the circumference, well, 2 pi r, so 24 pi. All right? It says to leave our answers in terms of pi. All that means is that when we solve for x, pi is going to be a part of the answer, so I don't have to push the pi button in my calculator. Now all I have to do is multiply the two things I know, 50 times 24, and divide by what's left. And I get 3 1/3 pi. Okay? Or 10/3 pi. That's it. That's all you got to do. I know, right? Let's take a look at another one. Part over the whole equals part over the whole. 100 over 360 equals x, that's what we don't know, over the whole circumference, which is 70 pi. Okay? Again, 100 times 70 divided by 360, and I can do it all in one line like that. 19.4, and if we change that, it's 175 ninths, or if I want to make it, look at all these fancy things you can do when you know how to use your calculator. 19 4/9 pi equals x. Okay? Easy enough. Let's take a look at this one. When I'm not given a circle, I'm telling you, it's just, it doesn't make sense to me not to draw it. Okay? I'm not a great artist, but I've got this fancy board that does this for me, and I just, you guys are better when you draw. You know, that's all there is to it. So I have an angle of 135 degrees, so we'll say it looks something, you know, and does the angle need to be exact? No. I just want something to work with. Okay, I've got 135 degrees. I've got a diameter of 24, which means I've got a radius of 12, and I'm looking for the arc length. Okay, so 135 over 360 equals x over 24 pi. Okay, and then we're going to do, where are you? 24 times 135 divided by 360, and I get 9. So x equals 9 pi. Okay. Here, I'm finding the measure of the central angle. This is a reason that I like to use the proportions also. So here we don't know the angle. I have no idea what that angle is. I'm just going to draw any old angle. I know that the radius is 6, and I know that the arc length is 4 pi. So the angle, we don't know, I'll use A for angle, over 360 equals the arc length, which we know is 4 pi, over the circumference, which is 12 pi. Okay? So I'm going to take 360 times 4, and I get 1440. Okay? 1440 and divided by 12. And I get 120. So A, the angle, was 120 degrees. Now some of you might be asking, well, what happened to the pi? Well, the pi's divide out to 1 right there. So this just becomes 4 times 360 divided by 12. Okay? Let's take a look at one more. If the central angle is 90 degrees, that's not a circle. If the central angle is 90 degrees, let's draw that. Let's label it 90. And the length of the arc is 25/4 pi. Find the radius. Alright, so let's set this one up. The angle over the total equals the arc length, 25 over 4 pi, all over 2 pi r. Because that's what we're looking for. Okay? This looks complicated, but if you just go through, when you cross multiply and simplify and all that kind of stuff, you get the answer pretty easily. The pi's divide out very early, so that's nice. 2r times 90 is 180r, so I'm just cross multiplying. 360 times 25/4, so 360 times 25/4 is 2250. And then I'm just going to divide that by 180. 12 and a half, kids. The radius is 12 and a half. That's it. All right. Get ready to practice that stuff. It gets a little bit, it doesn't get any more complicated. You just got part over the whole equals part over the whole, and then you got to have some good algebra skills. This was a blast. I've really enjoyed it, and I'm looking forward to seeing many of you very soon. If you have any comments, questions, anything like that, see me on Twitter, post in the comments below, or keep them to yourself. You choose. See ya.